Now, R is a very powerful package for visualizing data, and when we are dealing with lots of data, R comes very handy. Now, to read a file, what we can do is simply click on Import Data Set. Now, my data file is on the desktop, so I'll simply click from text file. So now you can see it gives you a preview of the data. So there are various columns like vehicle, FM, mileage, and so on with the data. So there is a title or heading at the top. So we should choose yes for heading. And then if you simply say import, your data gets imported into R. And you can see this data file here. So I would say you close this. The data file is going to be here anyway. And you can see on the right, you can see that there is a vehicle data file which has 7 variables and 1624 observations. Now if you want to look at that data, remember when you imported, like use this option to import data set, R automatically generated some codes that you can see here. So it was able to read this CSV file from the desktop. So this is the link or path where the file was, and then using view we were able to see that file. So you can see those variables like vehicle number, FM is a failure month, mileage like miles at which a car has failed. So this is a vehicle failure data. LH is labor hours, how much time the technician took to correct the problem. LC is labor cost, material cost, and the state in which vehicle failed. If you want to look at top few rows, we can say head vehicle and run this, and you can see top 6 rows are shown here. Similarly, tail, and then you have bottom few rows shown. Now, one of the simplest visualization tools people use is a histogram. Suppose we want to make histogram of this column LC, labor cost. In R, you can simply type HIST for histogram, and then you have to tell which variable you want to use from the data file. So our data file is called vehicle, and then to indicate which variable you want to plot in the histogram, you have to use a dollar sign, and then you can say LC. So when you run this command, on the right side you can see there is a histogram. If you have any question about any command, a simple thing is in the console, if you type a question mark and HIST and hit enter, it will bring up some R documentation related to HIST. So you can see that this command HIST for histogram comes with several options: x-axis limit, x labels, main heading, and so on. So let's try to do that. So we'll say HIST LC, and I'm putting a comma, and then I'm going to hit enter just to keep everything clean. So I'm going to include one of the options called breaks, and I'm going to specify breaks as 30, like how many bars you want in the histogram. If you want to limit your x-axis, you can say xlim equals, and then we can specify within C. So 0 to 1500, comma 1500 are within brackets. And then again, I'm putting a comma and hitting enter. And I want to specify y limit equals C, and again 0 to, so if you go back to plot, so y-axis seems to be actually more than 800, so I would say maybe 1000. We can also specify color of the bars. So let's say we want to make it green. We can specify X labels Y label, main title. So once we have all this, we can select this whole thing and run them at once. So you can see there is a histogram. So now because we have increased number of columns by specifying 30 and y-axis, now we can say actually 500. So instead of 1000 I would say 500. You can always play with that and see what you need and get appropriate histogram. If you don't like green and you want to have a blue color, you can try that by simply changing color to blue. What this histogram shows, you can see it is a right skewed histogram. It is not a symmetrical histogram because the tail is on the right side and most of the observations are located between 0 and about 400. Most of these type of vehicle failure requires labor cost of about $400. But there are some vehicles that end up where you end up spending about $1,500, which is obviously a lot. But it is very, very rare. Maybe there were some other failure modes involved. But majority of the cost is within 0 to 400 or 300 maybe. So histogram, as you know, shows three things. One is what is the shape of the histogram. In this case, it is right skewed. Where is the center of gravity, like where most of the values are concentrated. So in this picture, it is somewhere here. And histogram also shows you how much variability exists in data. So in this case, it goes from like 0 to almost 1500. One of the variables in this data is state. So suppose you want to see for each state how many vehicles have failed. So we can say, we can type here vehicle and then state. Now please note that because in state S is capital, so you have to use capital S. If you use a small case S, you can try that. Try running with the small case S, you get some error. So I will change it to S. And then you can also look at the way I showed you earlier, like a question mark and plot. So what options exist with plot? You can always play with those options and modify your graph to look better, just like what we did with histogram. So simply use pi and then you have to say table and specify the variable. So in vehicle data file, my variable is state and then run this. So again, it may not look very clean because you have like 50 different states and number of failures in some states could be very small, but some top ones are, you can see here, California, Texas, Florida are the top 3 states out of all the states. You can type box plot. Now the way you specify the variables in box plot is something like this. I'm going to use mileage variable and then this is a tilde sign and then I would say state and then put a comma and then specify name of the data file. So vehicle. What it will do is it will draw a box plot for mileage variable separately for each state. So for each state there will be one box plot. So you can be anywhere in the line and then say run. It gives you box plot for each state. Box plot indicates like if the box is higher, that means in those states failures are occurring at higher mileage versus if a box is low, then failures are occurring at lower mileage. It could tell you a lot of information about how the failures are occurring in each state. Another common plot is scatter plot where you deal with two variables. So for that also we can use plot command and specify two variables. So suppose we are interested in labor hours and labor cost and specify labor hours LH. So I'm using that name from the data file and then put a comma, again vehicle and labor cost. So if you run this, it should give you a scatter plot. So this is the scatter plot. The relation between two variables, labor hours and labor cost, is very clear. It is a linear kind of relation, which means when the technicians spend more time on a vehicle problem, the labor cost goes up. So when labor hours go up, labor cost also goes up. So more or less a linear pattern. You can plot several scatter plots at once, and this is done by using a pairs command. As you know, scatter plot is done only for numerical variables, so we should not use non-numerical variables. And in this case, for example, state is not useful. We cannot make a scatter plot including state variable, and we'll also not use the vehicle column. We'll ignore first and last columns. We only want to deal with two. Second column, which is FM failure month, then third mileage, fourth, fifth, and sixth. So I would say vehicle, and this is how you specify which columns you want or which variables you want included. So once I run this pairs command, this is what you get. So for example, this plot is for LH and LC, so labor hours and labor cost. Similarly, this plot is for labor hours versus machine cost. So the relation is not that strong. Between mileage and failure month, so although relation is not that strong, but it is positive kind of relation. As mileage increases, failure month also increases, or vice versa. And that is expected also. So if you look at this command here, before using scatterplot 3D, they have called a library. Now when you are doing this for the first time, you will have to install this package called scatterplot 3D. So let me show you how to install this package. So when you are in R, you should click on packages and then hit install. And then you can say scatter plot 3D. In fact, it's already there, so I can select that and say install. Once I wait for a few minutes, maybe a few seconds, it will be done installing the package. So once it has been installed, then you don't have to actually install this again and again. You only need to install once, and then you can call library. And then we can use this command scatterplot 3D. So it gives you a 3D plot. You can always like change the labels, names, colors by changing the options. So there is a contour plot. So if you want to try, I can simply cut and paste. Obviously, this plus sign we don't need. So what this command is doing, it is using inbuilt data called Volcano and then making a contour plot. So if I select this whole thing and run, I'll get what is called contour plot. So this command also is using the same data, inbuilt data called Volcano, and then giving some values to other parameters. It gives you this kind of 3D plot.